Good evening. So, welcome to our 4th eBay Tech Talk. Today's evening's topic is Mobility is lean way to microservices. And next to me is Jan Ehrhardt, architect at software architect at Mobility Commercial.
So, can you hear me? Great. So let's start. I'm Jan Ehrhardt. As already said, I'm software architect at the commercial group. So basically, Mobility is a little bit bigger than probably some other companies here in Berlin. We have multiple groups, and each group is built of a couple of teams. And the commercial group, does things with money. So today we want to talk a little bit about microservices. But before we come to this microservice stuff, which is some kind of hipster thing, I would like to. Oh no, what's happening here? Okay. But before we talk about this, I would like to give you a simple, a basic introduction where we are coming from. So, as most companies, we started with something like this. We have some kind of big software. There's some web layer inside. Over the time, there came some API layer. Well, it's just another kind of speaking HTTP to this application. And there's a big database where all the data goes. It's a single database system. Well, nothing special, relational database. The whole software is written in Java. It's Spring. Well, who of you uses Java? Well, that's good. Not so many. But while this is the old architecture, and we want to go away from it, let's first look on why it's basically not so bad. Because this monolithic architecture has some advantages, like there is a consistent tech stack. Well, it doesn't matter if it's written in Ruby or in Java or whatever, but there's just one language. There's only one framework, typically. There's only one library for doing JSON parsing and serialization stuff, most of the time. So you can have this tech stack very consistent across the whole application. And a monolithic application is very easy to set up if you're a developer. Well, you clone the Git repository, you install the language runtime, you install eventually a database and run the stuff. Well, there's nothing special. No further dependencies or things like that. It's just run it. So very easy. And of course, you can have a consistent code base. Well, this requires to be a little bit disciplined, but well, you can have that. You can check your code styles, so they are all the same, because it's only one language, well, only one kind of developer, all writing the same style. You can apply the same patterns. So, for example, if you use a model view controller pattern, well, there's a model view controller pattern for all. And there's nothing special. So, this is also a good thing. And of course, a monolithic architecture allows you to be very consistent when it comes to upgrading libraries. You upgrade a library just once, and the whole application gets it. Well, this can be some trouble from time to time, I know, but at the end, you get this kind of consistency. So when you upgrade, even if it's hard, well, you upgrade it for everything in your application. So no security holes left or something like that. So basically, this is also a good thing. And of course, you don't have remote calls. So remote calls, well, they take some time. And you have to go through the network. And the network can be down. Or the endpoint on the other side can be down. Or something else can happen. Well, remote calls are not the best thing. Oh, no. What happens now? Okay, and what is about data? We have one database, so no distribution and no problem with inconsistent data across multiple databases. Not so much fun to fix this. So you see there are a couple of advantages of having this monolithic architecture. And especially, who of you knows who David Heinemeier Hansen? I don't know how to pronounce it. Well, DHH. Who knows DHH? Well, not very. Oh, quite a few. Well, he is the creator of Ruby on Rails. Who knows Ruby on Rails? Some more? Great. So if you don't know him, Google him tomorrow. You can learn some really interesting stuff from him. And he has also written a great article about the majestic monolith. So this is a good idea in general to have a monolithic application, and he is writing about that. And typically when you're doing Ruby on Rails, well, the result will be a monolithic Ruby on Rails application. And that's not ha. Damn. Okay, you can learn some interesting stuff from him, especially that the monolithic architecture is something very good. So why should we do this? And especially at Mobility, we are not a company doing always fancy stuff. We are doing things only if there is a good reason for this. Because our business is to sell, or not to sell cars, but to to let people find the best cars for them. So the reason why we are talking about microservices today is an economical point of view. So the whole microservices thing is just, in general, the alternative to a monolithic architecture is just for economic reasons. And yeah, as the title of the talk might already mentioned, well, we are also talking about lean. So maybe you have heard something about Kanban. Well, that's not what I mean with lean. Lean is basically much more than just having a board and some post-its on it. Lean has something to do with some very special principles on how to work, and it's an economical thing. You can put it just in one sentence with create value while reducing waste. That's basically what's behind everything that is about lean, including Kanban. So basically the idea of Kanban is to have a tool that helps you to reach this goal. So in general, sounds good. But what has this to do with microservices? Well, the interesting thing is this lean stuff can be applied to a lot of things. One really weird thing is, for example, startups. There really came people and said, well, there's also a lean startup. And you think, what? Lean is about reducing waste? What the hell should this have to do with startups? A waste startup or whatever? Well, there is really a good idea behind it, because even even a startup is creating something, and it is also producing waste during doing it. So the conclusion of the whole lean startup thing is something like find a business model by building an MVP. So this is what we have seen above. The value of the lean or of the startup is basically to find a business model. Well, basically a working business model, not just any kind of business model, but it is to find a business model for the investors, for example, who want to make money with this stuff. And you're trying to reduce waste by building an MVP. So an MVP, who knows what an MVP is? Okay, it's short for minimal viable product. So it is a product that is not containing everything that the product could eventually contain. Well, it is just the minimum that is still viable to the customer. So with the minimal viable product, you just develop the minimum that you really need to develop. And if it doesn't work, well, you didn't invest a lot of money, just a little bit fewer money. And this is exactly what it means, reducing waste in a startup business, reducing the amount of money you waste to build something. So the interesting question is, when it comes to software development, what is our waste? Do you have an idea what the waste in your company could be? Maybe the paper on your desk or whatever? Well, it's pretty simple. Most companies start small, and there is not much waste. But then they start to grow. And there is no longer a 5-people company, well, there's a 20-people company, or a 50-people company, or a 100-people company. And with a growing team, well, there's also coming overhead. Well, there's, for example, some overhead in doing planning. The different people need to communicate with each other because they are all working on the same code base. So 100 people working on the same Git repository, on the same class all the time, whoa. They should at least talk to each other to coordinate this. And of course, this results basically in people like me. Architects are just some kind of overhead that you need to handle this overhead, or to handle the size of a team. And all of this is waste, including me. And so the basic idea is that we want to get rid of that. So what all the agile people are telling us for some years now is build small teams and let them be independent. So it's like making, well, instead of having 100 people in one team, put them in 20 teams and each works like a 5-people company. Well, great idea. So you can get rid of all the management stuff. Really cool, but it doesn't work. And the reason why it doesn't work is simply you're still working on the same Git repository, on the same application, it's still the same monolithic stuff. You still have to talk to somebody who tells you, well, that your code is wrongly formatted, because everything should be consistent. So basically there is some dependency in your daily work through the monolithic architecture. And that's exactly why this is a problem. So what we need to become independent is we need some kind of modularization. We have to find a technical fix for the organizational problem. And this technical fix is basically introduce some kind of modularization to your technical system. This modularization will help you to work independently. But, well, the problem with modularization is always it's not for free. There's always some technical overhead. Let me give you some example for this. Who knows OSGI? Or still remembers? Well, OSGI was a great idea. You start a Java runtime and launch this OSGI container inside, and then you can install whatever kind of things at runtime that you want. And you can remove it again, and you have multiple versions of the same library at the same time in the same Java runtime running. Sounds really interesting. The reason why nobody is using it today is, well, this introduced a lot of overhead you had to deal with. So basically you had to think about, oh, how can I install this stuff? How can I update this stuff? You had to build all the stuff yourself. And it was not that easy. Another great example for modularization is the Android system. If you look a little bit deeper into how Android basically works, well, of course, it's a Linux system, and yeah, there is some kind of Java-like runtime on it, but well, if you look really how the apps are working, well, they are Linux processes, and there are users per app. So you have some kind of sandbox there, and you have an app store to install this stuff. So basically, it's kind of modularization. You have a platform, and you can extend this platform with some kind of app. There's a clear interface, and it is really a great working example of modularization that allows independent teams. Because not all the app developers need to be hired by Google. They can just put the SDK there, and the people are working with that independently. They are making even money independently. So this is really like every app could be done by a 5-people company, or even fewer people. So there are approaches for building modular systems. But, well, Android on the server side, doesn't sound like a good idea. And OSGI, well, I hope it's almost that. So this whole microservices thing is just one kind of building a modularization for your system. So at the end, we also can translate this thing to building software. The value we are creating is we are creating features. But now we want to reduce the waste, and we do this by building modules. Similar to the MVP on the startup side, we are building modules in a modular system to get rid of all this waste, or at least start with getting rid of that. So let's go microservices. But one thing about microservices, what exactly makes microservices such a good idea for modularizing such a monolithic web application? Why the hell should we use this? Why not really using another system? Because, well, it's also distributed stuff, so it makes everything much more complicated. Why don't we use something else? And, well, one of the reasons is the technologies are already known. Well, if you're developing a web application, you have to deal with HTTP. Doing inter-module communication through HTTP, well, you know already the protocol and how to deal with that. So, well-known technology. Well, you are running currently, we were running at least a Java application. Well, we know how to run a Java application, especially on a Linux server. So running just a couple of them is not something new to us. Our ops guys know how to monitor a Java application, and we know as well. So there is already knowledge about the technology, and it doesn't change. And of course, we are using existing infrastructure. We have already a continuous integration built, and we can just reuse it for all the modules as well. Nothing special, still the same stuff. And of course, we also know how to deploy our software to some server. We don't have to invent an app store for our own platform. We can just use what's already there. Even more important, there is a community. We are not the first people who try to build some service stuff. Many companies have done this already in the past, and, well, they are talking about this. They are sharing the knowledge. They're on conferences or on meetups like this. They are sharing the knowledge about all this, how to modularize your system based on services with others. And they have, some of them have also created some great open source tools that you can just reuse. So there is also some technology that you can reuse. Technology provided by others who were already gone through all the bad parts of it. So the community is a big advantage. So applying this microservices approach to modularize your system to become more independent, well, it is at least the best you can have at the moment. Well, maybe in 5 years there might be a better solution, but at the moment, well, let's go with microservices. So then we came and thought, okay, where should we start with that? And well, there is no good answer to this. The best answer I can give you on where to start with migrating to a microservices architecture is just to do what we said previously, build features into modules, so start with the next feature. It's the best guess you can have. So the next time you're implementing a new feature, a new user story, or however you name it in your company, well, build a service. Sounds easy. Is really tricky, but, well, you have to start somewhere, so use the next feature for this. And never miss to use a feature for this. Never think about, oh, we have to remove this technical debt. Well, no, technical debt is a myth, so don't care about technical debt. You should care about building features. You should deliver business value or value for your users. And this is why you're building microservices at all. If you're not implementing new features, well, you don't need to touch the system at all. So why migrating to a microservices architecture? Oh, solve issues. Well, from time to time, there are some issues. Well, especially if you're beginning, they will just pop up everywhere. So don't care about them. Solve them when they occur. Don't try to optimize everything before. Because you have so many issues, well, you should just do what's necessary. So this is how we started, basically. We had a new feature that we wanted to implement. Well, we wrote a service for that. Well, that's not a big deal. Well, then we thought, okay, we should also use this new feature in some way. So we also put a web interface in front of it. Well, this was also integrating with some old stuff, so we put something of the old stuff into a service. So we could also use it and let now the new web interface work on this. And we could also put an API layer on top and let this also access the same functionality. So basically, well, all of these rectangular things are some kind of service. Some of them are serving HTML, some of them are serving JSON to the world, and some of them are running internally in our system and have a database. So nothing special so far, except that we now have a lot of remote connections involved. And everything is in its own Git repository. And everything is owned by a single team. So everything was developed by another team independently. And well, one of these services we started to write was, for example, written in another language. We started to build a service enclosure just because now we can. And we later see that there are more reasons than just you can. But we were going further and we're implementing the next feature. And now we thought, oh, well, there is this service and we want to build a new feature and, well, we could put it into a new service, but now we have to ask another service. Well, introducing new problems. Well, we have to solve them. So when one service is called and it's calling another service and the other service is failing, what are you doing? Are you also failing? So many of your requests might be failing because this other service is just broken. Or are you serving just half of the response? Well, how does a client know which half you really served, or if there is another half that is just missing because the other service is broken? So it becomes a little bit tricky to deal with that. And well, we are not the first people dealing with that. For example, Netflix, they have even developed their own library to handle this Hystrix thing that can handle at least some of these problems. But at the end, you still have to solve them on the business level, because on the business level, you have to decide, should I fail or should I just show half of the content? And should I also tell the user that he's just seeing half of the content, or should I just show him the half and don't say anything? So it's a little bit tricky and creates new problems, but that's exactly what services are doing. So what we really wanted is to bring the data from one service to the other. And the approach we had was, well, let's just call the REST API of it. But then we thought, well, the Unix shell does it in a different way. You invoke a command, and then another command can use the result. Like this. You can run a find, and the result is just piped into another command and processed there. So the grep in this case isn't querying the find for the result. No, the data is just going through it. And there is this nice operator, this pipe operator, that does the whole trick. So what is the pipe operator for our services? Well, that's an interesting question. The Unix shell's pipe operator doesn't work, obviously. We have to deal with some network-based stuff. And, well, you can try a couple of things. You can try to simulate this kind of thing through HTTP. You can also try to use some message queue for this. Well, all of these systems are not designed for doing this. They are designed for some other use case. So you have to do some extra work. It's very similar to, let's say, an Apple Watch. An Apple Watch has this small LCD display, but this display is consuming so much energy, so they had to develop an algorithm on top of that that switches off the display, because it should save energy. And then it tries to detect when you are looking on your watch and tries to detect this moment to switch it on. And the first time users, you always see them to turn on their displays, because it's the wrong technology for the use case. Well, there are other smartwatches that have an e-ink display. Well, this is always on. It almost consumes no energy. So, well, it's like made for the use case. So if you want to use HTTP for this or a message queue, well, it's simply using some technology where you have to put some extra stuff on top to make this work. So it's not a good idea. But there is a solution for that. You can use a locked data structure. Who of you knows what a locked data structure is? Ha, great. There are some people. Few of them, but there are some. Great. Well, a locked data structure is basically, well, a sequential data structure where you can only append to. So everything goes at the end. Well, that's simple. But there is something really interesting about that. There is an historic order in the sequential data. And it's therefore, well, it's natively there. You don't have to do something for it. It's just it's exactly how this data structure works. So how does this data structure help us? Well, long time ago, some people already built some systems that are using these data structures to put data to another machine. Especially databases are doing this. If you write data to the database master, well, the master will write it to some kind of changelog. And this changelog will be sent to all the slaves. Well, this changelog is obviously a log data structure, and it will be sent to all the slaves, and all the slaves will just process the log in its historic order, because it is historically ordered, so they can recreate all the tables. And this is how most database systems are doing database replication. So how to bring data from one machine to another machine is already a solved problem. But sadly, it's just solved, well, in some database systems, and all did their own implementations, and, well, you can't reuse it. So how can we bring a log data structure to our system? And we were not the first people who thought about that. There was this guy, Jay Krabs. He was, well, I don't know how to pronounce it, but I think Jay Krabs. And he wrote a book about this. Well, this is really the title of the book. And it's hard to Google this title, by the way. It's typically named, so the normally written title is I Heart Logs. So, well, but the official title is this one. So this guy really wrote this tiny book about how to use log data structures and what the advantages of them are, and so on. But this guy did another thing. He worked at LinkedIn. And at LinkedIn, he had the chance to build also some software. And this software became open source. And some of you might already have heard about that, because the software is named Apache Kafka. Apache Kafka is, well, many people think it's a message queue, but it's not. Basically, Apache Kafka was built as a high-throughput distributed log. So you have a log data structure. You have a server that provides your log data structure that is distributed, and you can just use it. You don't have to do something for it. So, so we tried to use Apache Kafka for doing exactly this data pipe thing that we also have on the Unix shell. Well, it's not that easy than typing a character. Well, Apache Kafka is a little bit bigger. It requires its own machine. Well, there's some kind of protocol involved, some native Java dependencies. They have their own TCP-based protocol, so you can't use it in whatever way you would like to do it, and some other stuff. But basically, you can have a nice operator who installs it on a machine, and then you can play around with it. So we did. And our first approach was, oh, we have this Kafka, let's use it. We want to pipe data from one machine to another. And then we thought, okay, but we also want to join data from two of these topics. So in Kafka, it's named a topic. And well, joining them is a little bit tricky because you get the data and well, it's some kind of randomly coming to your machine. So over time we learned a lot about Kafka, and especially that it's not really a problem to do these kind of things. Because, well, if you know how Kafka works, it is like the following. You have a topic, and the topic is separated in a couple of partitions. And, well, each partition is a lock. Not the whole topic, just each partition. So the order is just guaranteed per partition. So the interesting thing is, how does Kafka calculate on which machine to send a message? Well, you can provide a key for a message, for example, an identifier. And, well, there is a clear algorithm to calculate from a key the target partition. They just calculate a hash over the key and calculate it modulo the number of partitions. So if you have the same key and the same number of partitions in a topic, it will always be the same number, the same partition number to where the message will go. And this is cool because, well, it guarantees you that all messages with the same key will go to the same topic. So order is really guaranteed. And it also guarantees you that this happens across topics. So if you use, for all topics, the same number of partitions, well, and the same keys, well, then you know the data that belongs together is at least on the same partition number. And we also learned that consuming works exactly in this deterministic way. You're launching on the consumer side, a consumer, and subscribe to a topic. And what Kafka does, it has a clear algorithm how to calculate which number of partition will be assigned to which consumer. And with this trick, you get simply that all the data from different topics, if they have the same number of partitions, and you use the same key, well, all the data that belongs together will also finally end up on the same machine. That's cool, so you can just join it. And we learned other cool stuff about Kafka, like lock compaction. Well, by default, Kafka throws away everything that's older than 7 days. Well, you can extend this period to 30 days or a year or whatever you want, and integer max or whatever. So this can become very long if you want, but there's still the risk that something is thrown away from your lock. So how can you put all your data to the lock? Your whole database in one lock. How can you get this done? Well, you can activate lock compaction on the topic, which basically means Kafka doesn't throw it away anymore. Instead, it at least ensures that for each key, at least one message will stay alive, the latest. So now you can have, for each key, a message in the topic. So you can just reprocess the whole topic and just recreate your database. And, well, you also can delete messages because you would have a lot of waste in your topic if you can't delete it. This is simply done by sending null as a value. So with this, we became able to really build something with kind of pipe operator. Well, our pipe operator is a little bit bigger than just a single character, but, well, it basically works. And this allows us to do something really interesting with microservices. Because, well, we developed the first microservice, and then we wanted, and it was simply consuming, there was another one who was simply consuming the data from the first one. Doing something with the data, storing it in its own database or whatever, and become independent of this. If this goes down, well, nothing happens. This one still serves the data, because it has at least the required data kind of mirrored in its own database. And so we don't have a cascading call, or at least we don't have cascading call across different services. So now we came up and said, oh, let's build another service, because there was another feature that was related to this in some way, but there was another team. And, well, our goal is to make teams independent by building services. So obviously, new team, new service. don't reuse the service of the other team. So, well, how to do this? Well, they put just another service there, and it was also consuming the data from here, and it was doing some kind of extension to the data, and publishing this extended data just on another topic, so the first one could also consume the extended version. So depending on whether it's data that should be extended or not, it's consuming this or this one. With this little trick, we just could change this without changing all the services or touching the other services. We could just put something into the pipeline, just between it. So let's come to the most tricky question around microservices at all. You don't write a complete system and replace in a single night the whole old system. That's not how it works. So you have to deal in some way with your legacy application. It will still be there in, well, our application might still be there in 5 years. And of course, it's still working and it's still making money. And we don't want to replace it completely, especially not in one night. So we had to deal with the legacy app. A common workaround, I've done this a couple of times myself, and I've also seen other people doing this, is you have the legacy system and obviously it has a single database. So all the data of the old system is in just one single database. So what you can easily do is just put a service here that is giving you some cool API for a cool new distributed data, system, but let it under the hood go to the old database. So it's kind of faking a microservices architecture because you still have the single database as a dependency of all of this. Well, you don't get modularization through this, it's just faking. And there's especially another very, very important problem. This database is still the master of all the data. This is where the truth is. So whatever you're doing here, you're just doing what's dictated by this side. So you never get to your new system. It's just like, well, like painting it in a little different way, but basically you still have your old system. And this is what I mean with a workaround, because it's not solving the problem. So how can we get out of this problem? Well, we already have everything we need. We have services that have their own databases, and these services are independent of each other, and they are emitting some kind of data through a data log. Well, it's like writing to stdin on a Unix shell. Well, in this case, a bigger Unix shell, but it's similar. And we are putting a service there that is just consuming different kinds of logs. Aggregates the data together, translates it to the old data model, and keeps the old database updated. So at the end, we change the direction. The old database, or the old system with the old database, will still be alive. It doesn't, well, it's not shut down. It could still work for a couple of years now, but, well, the truth is now on this side. So this is the ruling new system. Well, this is just the old stuff and you shouldn't touch it. And there is another great advantage of this. Well, if you get to the lucky day where you can switch this off, well, you can just throw away a single service and you're rid of all. So nothing is left. In the other case, before, well, you have all these dependencies on the old database, well, you have to solve this. This approach solves your problem, really. But you can still think about how do I get the data in the other direction? Well, don't get it in the other direction. Find ways to migrate stuff completely out of your system. Wherever you can avoid this, well, you can, of course, put another queue there and listen to this or whatever. Well, but whenever you can avoid the opposite direction, do it. Try to find a way to avoid this all the time, because otherwise you don't become lucky with that. Multi-dimensional slides are nice as long as you see that you have to go to another direction. Well, so probably something too complicated. Next time I will do something different. But let's come back to the initial idea. When we started to do microservices, or some kind of modularization where microservices fits best, well, we wanted to reduce waste. And, well, it's important to not leave the focus on this. Well, you start with microservices, and you think, oh, this cool new technology, and oh, cool, Kafka, and whatever. But what you really want to do is reducing waste. So get this back. So let's talk about some goals we have to reduce this waste. For example, the dependencies. Well, this is why we are doing this. We want to reduce the dependencies between teams during working. So what can you do in a microservices architecture to deal with this kind of dependency? Well, you can, for example, say, oh, there's this team having ownership of this service, and another team wants to implement a feature and they need something in this service. Well, then you can say, oh, please, other team, can you implement this for us? And we need to serve it to this deadline. And the team says, yeah, you need to serve it to the deadline, but not we. So we can serve this to you, but not until your deadline. Great. This is exactly the kind of dependencies you don't want. So what can you do how can you solve this? Well, a very common approach, if you have something like GitHub, you can do pull requests. So one team is owning the service, and the other team has a problem, solves it itself, and provides a pull request. Well, great. So we are working again on the same code base. We are back again on the same monolithic thing that we had previously, where we are all working on the same code base, except now it's distributed across a lot of Git repositories. So you don't win anything with that. You just have still dependencies on someone else's work. But we have already seen the solution for that. It doesn't matter if a use case is handled by another service in general. If this other service is built by another team, built for your use case, a new service. Well, this will fragment your stuff a lot, but it will make you independent. So this is exactly why we have built this way. Because instead of letting the team that built this service could also have fixed the stuff in this service, but they didn't. They built their own service, because then they could choose their own technology, then they could have their own architecture, their own code starts, their own libraries, and of course, they could have the ownership about that. So they could make sure that everything is working or not. And at least they could say, well, our service is working, but the service of the others is not working. Which is not nice, but at least they can control that everything they build really works. So these kind of dependencies, probably you want to measure if this really works or how good you are. So there are a couple of metrics you could, well, there are a lot more metrics you could apply, but these are typical things when it comes to this kind of waste. If you want to see if you're really reducing waste, well, measure at the beginning, measure at the end, and see if the value is smaller at the end. You can look, well, the team dependency per feature, how many dependencies were there. Well, you can see, you can look on the pull requests. If pull requests are happening, something is going wrong. And of course, you can think of a lot of dependencies that fit to your company in a better way. So does this really solve our problem? And the answer is obviously no. Because now we have reduced the dependencies and we have created a lot of extra cost. So how to get rid of that? All the extra costs of microservices. And there is a lot of this. And it's not just telling you, because we really had this. I know there is some extra cost of doing microservices. So the best thing you can do is automate and then find some standardization for that. Why not the other way? Well, because it's easier. If you first automate a problem and then make this a standard, well, it hopefully becomes a de facto standard and then you make it officially. So if you do it this way, it works. The other way is just talking and talking and talking and talking until you get a standard, and then you figure out that the standard is not working because you can't automate your problems based on this standard. So always go for the de facto standard by automating and let everyone use this. But this is exactly the solution how to deal with the microservices extra code. So we had a couple of them. And, well, not the obviously first thing, but the first thing we met was the login stuff. Well, I have shown you this diagram with the multiple web applications. So you have multiple web applications all built as a separate application, separate Git repository, some of them written in Node.js, some of them written in Java, and some crazy guy might already start going with Go. So, well, how to deal with that? There's a common problem. All of them need to log in. And all of them need the same kind of navigation on the top of the page. And all of them need the same search box on the top of the page. And all of them should have the same analytics script somewhere included. So we figured out that there are a couple of things every web application has to serve, if they want or not. So what we did is simply putting a proxy in front of it. Well, more or less a proxy, but putting a proxy in front of it that is taking all the incoming web requests first. And, well, whether it's logged in or not, it will redirect to the login page, handle the login, and so on. And if it's logged in, well, it will forward the request with the logged in user information to the web application. And this is cool because nobody needs to implement authentication anymore. If you want to create a new web application, well, don't care about the login because it's already there. You just put it behind a proxy, login solved. Pretty nice. Speeds up everything. And especially the login was done with a servlet filter before. And migrating the servlet filter over to Node.js, well, not so much fun. And the same is with common UI components. Well, we created another service to put these kind of components there. So they are not on the proxy, but basically the proxy knows how to load them and how to put them in the page. So nothing special. This proxy is already there. It enhances simply the outgoing response by adding something to the HTML. So also, this is solved in general. So every web application you write doesn't need to care about that. Well, in the case of the header, for example, with some navigation and so on, there's also some CSS involved and some JavaScript. You should at least care about it. But it's another kind of caring about it. You don't have to implement it yourself. And you don't have to use a library. And then that library will be changed because you want to change your company color. Well, then you have to upgrade to the newest version of the library in all your applications. Well, we don't need to. We just roll out the new version of the service, and every page, whether it's written in Node.js or whatever, gets the same navigation. And it's working. Well, we have already seen this log stuff. And, well, one of the problems coming from this is that Kafka is a nice technology in general, but there are some disadvantages. Well, you have to know how to consume the stuff that is coming from a Kafka topic. You have to know how to produce it. Well, you have some dependency on their own Java client for this. There is no standard protocol except TCP under the hood. And a couple of other things like how to deal with consuming continuously and registering enough consumers and so on. So one thing, well, we are not doing this at the moment. We're currently thinking about it, to be honest, because, well, obviously you're creating an additional latency. There is additional network traffic in this idea. So what we want to do, or we are thinking about this, is that a producer could just send the data via HTTP to a service, and the service is adding it to a Kafka topic. Well, the service is also consuming the Kafka topic and sending the data to one of the clients. Well, the client, when it starts up, or the consumer, when it starts up, simply registers. It says, well, I want to hear something from this service, and you can send the data to the following URL. So basically, this data log service knows to which URL to post all the data. And there are a couple of advantages of this, because, well, you don't have to care about anything. You just need to implement another REST API, another resource in your REST API. It's something your service already does. You just put another endpoint there. It's nothing special. You don't have to deal with another dependency on some kind of tool. And, well, then you upgrade the Kafka server and all the applications have to upgrade their Kafka clients. Well, it doesn't happen. You encapsulate the whole complexity of Kafka in this single service and can make it very easy by speaking HTTP by all the clients. Well, the problem is, well, there is this additional network traffic, and we are currently not sure if it's worth to put this traffic to the system, because, well, one of the problems in such a distributed system is that you have latency through additional network traffic. There is this advantage of the monolithic architecture, no remote calls. Yeah, this is the opposite. But there are other things that are easier to have. One of them is automating the setup of your CI server. Because with every new service, you need a new CI build to build your code, to run your tests. At Mobility, we have a very cool solution for that. We just put a small YAML file called Jenkins YAML, or jenkins.yml, to the Git repository, and our Jenkins server will detect this and will read the configuration out of it and create automatically all the jobs required for this service. Really nice feature. It's a little bit working like Travis CI, and makes everything much easier. Because adding just, well, 3 lines of YAML configuration to your Git repository is very easy to do. And you don't have to go through different forms and click on different buttons to get something you didn't want. If you're using TeamCity, well, also not a big problem, because there is this templating stuff. So you can create some template configuration and then let builds inherit from them. But, well, it's not that comfortable than having a jenkins.yml file. And of course, you can also go with something like Travis CI. If your company policy allows to go to the cloud, well, do it, because they have already solved the problem in a very simple way. But don't forget to automate this. Because with a microservices architecture, and if you're really writing many of the services, if you're doing this seriously, and you really want to become independent with your teams, well, then you should take care of this kind of waste. And the same is true for deployment. You should automate your deployment. Whenever someone is merging something to the master branch, well, there should be an automated build, which is building the software, and it should be deployed to the live system, of course, automatically. Why? Because, well, you can also configure the deployment again and again and again, and this will introduce new failures. So automate it, and you're done with that. We are not done with that at the moment. We are still working on making this continuous deployment working at Mobility, but we have very good tools for that. Our software is running basically on a Mesos cluster with some tool on top of that, Marathon, to manage this. which is really nice to use, and we have some Docker containers running in it. So Mesos is starting the Docker containers. That's it. And there is a nice advantage of doing this, because normally you can also create for every new service a new machine. Well, you can also create new Puppet setup for every machine. But this is just additional overhead. This is not reducing any waste, it's just creating new waste. So this Docker container approach is much better. You have just a single machine, which is basically part of the Mesos cluster. It's always the same setup for all the machines. And you just throw some containers on them. So you have some abstraction here that makes the application or the deployment of the application independent from a running machine. And of course, you should also monitor your applications, and you should also automate the setup of it. Well, you can create some kind of library that you can share across all the different applications to have the same kind of setup, using the same properties or whatever. Well, you can also have, and this is something we are doing more and more, have common dashboards for that. So if you're using some kind of dashboard like Grafana or the Kibana stuff or something like that, have a common one, not a single one per service or a single one per team. Use one for multiple teams or the whole company, for example, and let all the applications go in there. A great example is errors. If you want to create a Kibana dashboard to see how many errors are logged, well, it's great to do this across all your applications. Because it doesn't matter which application had the errors. If there are errors logged, someone should react to that. Someone should do something about that. So having a common dashboard is okay. And it's much easier to handle, because nobody needs to set up a new one. There is already one, hopefully one to which developers are frequently looking. And, well, if you create a new application, well, the logs will automatically go there. If the new application is logging errors, well, they will appear in the existing dashboard. So this kind of having common dashboards that work across all the applications makes the setup much easier. Although it doesn't work for all cases, but wherever you can use it, try to use it. And there's also this problem with dependencies. Well, in a monolithic architecture, well, you don't have the problem. You update dependencies in your application, and they are updated for all parts of your application. With microservices architecture, this is not so easy. The best thing I have seen about this is a tool called Greenkeeper. Who of you knows Greenkeeper? Wow. I'm not the only one. That's great. So Greenkeeper does something really interesting. It will analyze your Node.js project's dependencies. And if there is, well, it could show you which is outdated. But it does something additionally. It will also create a pull request with the update. So it looks on npm.js.org for newer versions for the libraries you're using. And if it finds a newer version, it will create a pull request for your package.json. So you don't have to do anything else than just merge the pull request. But, well, Greenkeeper is the only tool I know that does something like this. So most of the time you need something else. So at the moment I don't see that there is a really good solution. So basically we are not using one. But I would really like to see some more automation on that. Other things you can automate is setting up the developer laptop. Well, with a monolith, it's extremely simple. Install a database, install a runtime, get the code, run it. Well, with services, it becomes a little bit more tricky. Well, your services use Kafka. Well, you need a Kafka, a database, a runtime. Well, some services are running on Node.js, some are on Java. Well, you need 2 runtimes. And there are a couple of other things. Well, each service you depend on, you need the service, you need its database, eventually additional stuff it is using. So for a single project or for a single service you want to work on, setting up the developer laptop becomes more tricky. But you can automate this. The approach we are following at the moment is to use Docker for this. So since we are working on the continuous deployment, we are also working on doing the continuous deployment based on Docker images. So, well, hopefully we will migrate over in the future to deploying Docker images to our system. And the cool thing on Docker images is you can also run them on your local machine. And there's a tool called Docker Compose. And once again, you have a simple YAML file in your Git repository where you declare the services you need and the databases you need and all the stuff, and you just say docker compose up -d, and everything is running in the background on your local system. Everything is fine, you can just start coding. It's like working with the monolith again. So this is a little bit more tricky. One problem we faced with doing microservices and especially distributing data is that services become dependent also on the data structures that are served by other services. So let's assume a simple example. You have some customer data here, and well, you have some other service that is consuming this customer data. Well, it's basically a name of the customer, to keep it simple. Well, then you write a new service, and it should extend every customer data set with an address. Well, a really simple example, but it should add an address to every customer data when it has an address in its own database. So you separate these kind of data. Well, the problem is that if you add other stuff to the customer data, you have to fix this service to also know about this data. And, well, this is a very simple example. It becomes much more tricky if you extend this. The problem is that this service depends on data, or on this data structure coming from the other service. Because, well, the data it's emitting itself is also basically derived from the input coming in. And the typical problem that could happen is you write this service in Java. Why is writing a service in Java a problem? Well, Java developers tend to use POJOs. They use something like Jackson to map some JSON to a Java object and then back to JSON. And in the meantime, add some additional data. Well, the problem is with this POJO mapping that, well, it will simply ignore new attributes. And you have to touch the code and add additional properties to your Java class to get them involved. So whenever you add a new attribute here, you have also to add the attribute here. And maybe you have also to add the attribute here. And well, the chain can go on. So with using something like POJO mapping, you have a problem. A much worse idea is to not use JSON, but to use a data format that is having some schema, and also adding some schema validation to your system. Well, this is really painful, because then you add a new field here, and it will crash here, because the schema is not valid anymore. There is a field that you didn't expect. Well, this is really bad. So the best thing you can do about this is learning from the internet. On the internet, well, there is no fixed data structure. There is no static typing on the internet. There is only some kind of dynamic data. So on the system level, you should always think about data as something dynamic. Never think about it in a static way. Always be open to all kind of changes to incoming data. And always think about, well, if I add data to a service I depend on, well, how do I ensure that nobody else that is following me will miss some data because I'm using POJO mapping? Yeah. There was just a quick hint on the fact that Java is probably not the best technology to do this kind of dynamic data thing? Well, it's not just data. Let me give you another example. We had the case that a team was writing a web application. And they were starting with a Java web application with server-side rendering, and then decided during implementation, oh, we have so much JavaScript, well, we can do this whole thing completely with React.js. So the thing was simply refactored to become a single-page app. Well, that's not a problem in general, but, well, if you look into the code base, you will see a Git repository that looks like a Java project. But the Java part was nothing else than just being a simple proxy serving the data to the internet. So, well, it's not really a Java project. It has become a JavaScript project with some kind of Java code inside. So, if you think about these kind of applications, it makes much more sense to create Node.js applications here, or front-end projects here, and just put a simple server directory there where you put the scripts, for example, JavaScript scripts running on Node.js to provide you some kind of proxy functionality on the system. Especially since we have put the whole login stuff and some other stuff into a proxy in front of it and have already solved this, well, there is no need to put a big fat Java project at all in your code. You can just put some additional JavaScript files there and you're done. So the reason to think about a better tech stack here is not because, well, Node.js is so cool. No, it just fits better to the new structure your project got. Another example is Clojure. Well, we use Clojure, at least in one service. And as said, we did this because we can. But it's not the only reason to do this. The other reason is especially this data thing. When you have to deal with, when you want to deal with some kind of dynamic nature of data, it's much easier to use a language that is designed around data. And Java is not. So Clojure instead, well, Clojure, well, even the code is written in data structures. So Clojure is basically the perfect fit on dealing with data in general. It's just built for dealing with data. So trying out Clojure to deal with some kind of dynamic data, well, at least figure out if it works for you. There are other things on Clojure that don't work that well because the syntax, well, not everyone likes the Lisp syntax, but, well, at the end, it matters how fast can you be with using a different technology stack. And this is exactly the reason why we are not stopping with just trying Clojure and Node.js. We are also trying other languages. We are also trying Scala, for example, and, well, yeah, some crazy guy also introduced Go. Well, we are not doing very much with Go, and I hope Go will also go away again, because, well, yeah, I don't like to say anything about Go. But except these languages, well, we're now open to do this. And the great thing is, well, since we are starting to deploy Docker images, well, even this doesn't be a problem anymore. It doesn't matter if your application is put in a jar file or however you want to distribute it. At the end, it's a Docker image. And the rest doesn't matter. It even includes the required version of the runtime. So all your problems are solved. Or at least the problems you could have in this domain. So also on this second block, which is a little bit larger, you should definitely define some metrics to measure if you're on a good way or not. And it doesn't matter. So, well, the number of technologies you're using is obviously not a good indicator for anything. But instead, what is a good indicator is, for example, how fast are you to create a new project and bring it to the live system? And you should measure this in hours. And it should be lower than 1. And if this is not the case in your company, well, you should do something about this. Well, basically, it's also not the case at Mobility, but we are working on this. And there are also other things, like how fast are you to deliver new software? Because these are the things that are a problem with doing microservices. You are creating new applications all the time. Well, every second week you are creating a new application, bring it live, you have to maintain it. Well, you should automate whatever you can automate on this and measure that this is also working. But there's more we can reduce, more waste. And the problem, if you follow the stuff I told you before, if you follow this, well, there will be a lot of services. Well, they're popping up everywhere, almost every day a new service appears. Well, there's a problem with that. The problem is not the number of services in general, and the problem is not that the logic in your system is distributed or the data is distributed. That's not the problem. The problem is, the reason why this happens is because of team independence. So obviously, your teams are always working on something different. And especially in the commercial group where I'm working, we have really the problem that, for example, projects that are around customer data, for example, are randomly distributed across the teams. So every time someone else does something new with customer data, well, obviously he will build a new service for that. There will never be a customer data service because it's always going to another team. And if you want to reduce this, and especially the fragmentation of the knowledge across the teams, because nobody has the whole picture in his head or in his wiki or wherever, well, reducing this kind of knowledge fragmentation is also something to reduce the waste in your company. And there's only one way to do this. You have to introduce some kind of business ownership. We have this at mobility.de as well, but not everywhere. So if we stay with our customer data example, well, there could be a team that has the ownership of the whole customer data thing. So whenever there's something happens in the company around customer data, well, this will go to this team, not to any other team. So just give it to this team, and they will prioritize it, and they will do it. And this gives us a great opportunity. We can build this into a monolith for customer data again. So we can get back, for this specific domain, we can get back all the advantages of the monolithic architecture again. Well, the whole system will still be distributed and will still be built of a couple of services. And well, for new stuff where no business ownership exists, for example, well, it's still valid to build services. And all the investment you did in being very good at building services will make you faster for the future. But consolidating your system by bringing stuff together again and building monolithic architectures, at least for some of the services or for some of the business domains, is not a bad thing. There is no do monolithic architecture or microservices architecture. Well, you can do both and choose for every situation, choose the one that fits better for your needs. Never do something because, well, it's cool at the moment, and there are conferences around this, and stuff like that. So choose the better solution for your problem. And this can also be the monolith. And also, don't forget to add metrics to this. Like, for example, how many features have an ownership, or better, how many features don't have. Well, there are good reasons why you create new stuff without having a clear business ownership. For example, you want to try if this thing is really something your company should do or not. Business ownership is not necessarily needed here. But for the building blocks of your business, the really important stuff, the whole stuff where your business is built on, well, you should have some business ownership. So let's come to the last part before there are some questions and, of course, the soccer match tonight. So where do we want to go coming from this point? And now, well, we are not discussing so many things. There's just one thing. The thing where we want to go with mobility from where we are at the moment, somewhere dealing with a couple of problems to get better in building our system, well, we want to come to a point where we are really building a great software, and especially for our customers, because we are still focused on building value for our customers. This is why we are doing the whole stuff. We are not doing this because microservices are a hip thing at the moment. No, we are doing this to build better software for our customers and to become faster with that. So this is the reason why we are doing this, and this is the reason why we are focusing on it. So let me say thank you, and do anybody have any questions? Ah, there's a question. Maybe someone comes with a microphone? Or not? Ah, there's someone with a microphone.
Yeah, hello. You mentioned a proxy server, which one handles the authentication. Do you hear me?
Again, I didn't understand.
Do you hear me? Yeah, okay.
Yeah, no.
You mentioned the proxy server, which one handles the authentication. How do you transport the user data to other microservices in behind, and how is the way secured or not?
Yeah, it is, well, the way is secured as the way in our system is always secured. So, well, I hope this part of the question is enough. But how do we how do we transport the user information from the proxy that does the login stuff to the microservices behind? Well, the way we are doing this is using a JSON Web Token. Of course, this JSON Web Token isn't valid forever. It will time out after some period, and it is signed by some cryptographic algorithm and so on. The advantage of this is there are almost well, I don't know any language that doesn't have some library to support it. And we can just put it to an HTTP header and transport it further. And well, the JSON Web Token is just simple. What we can also do with the token is we can give it to other services in the backend. And this is also what we are not doing always, but we are trying to establish across the whole system that every service has at least, or will at least check if it gets a JSON Web Token, if necessary. And this is exactly how the service can detect or determine which user, for example, is logged in. So every service, well, no service asks some central session service or something like that for who is logged in at the moment. Everyone gets this token and see, it's user X, Y, Z, and well, I know what to do now. Other questions? Yeah. Wait on the microphone, it's better for the video.
If you want to run integration tests for some service, how do you do it? Do you mock all the dependencies, or you need all of them to be in?
To run integration tests on the services, it always depends on what you want to test. If you just want to ensure that your service is working, well, try to get rid of almost all dependencies. One of the reasons why we are thinking about putting an HTTP service or an HTTP API in front of Kafka, for example, is, in this case, your service loses the complete dependency on Kafka completely. So you don't need it at development time. You don't need it at test time, for example. So the best thing you can do is try to test as much as possible on your service without too much integration. What we are also doing is we have part of our deployment is typically that we deploy the software on a testing system where it is really integrated with almost the whole system. And well, we are currently looking into solutions for how to not deploy the whole system to the test system, but deploy at least enough. Well, this is not that easy, and we don't have a good answer at the moment. But, well, if you're interested in this, we are hiring. Other questions?
I actually have two questions. The first one is actually kind of a personal view. Since you're using different languages, how valuable or how easy do you think monorepos are? Because that's something, a hot topic we discuss at work right now, to combine a repo or distribute it. And yeah, I would like to actually get your personal view about that. And second one is, I met a lot of people using Kafka or messaging queues and stuff, and they're all complaining about some problem of that, not even framework, but that service. So how beneficial do you think to use a protocol that is out there and kind of have your own implementation in the long run, instead of using a service that is built and you have to deal with the dependencies or the versioning of that service? That's all.
Okay, let's start with the second question. Well, yeah, the problem with Kafka, well, Kafka is not a message queue, but well, the problem with Kafka is similar to other technologies, of course. You have some kind of dependencies you have to deal with. And one of the reasons why we are thinking about putting some kind of service in front of it is exactly to deal with this special part, to keep it separate, encapsulated in a single service. Encapsulation is always something you can do, always at the cost of having additional network traffic. But yeah, so at the moment it's the easiest solution I see on this, and don't have a better one. What I don't like so much is the approach of putting just an HTTP. The time, I thought the time was gone. Well, I don't like the idea of putting an HTTP proxy in front of Kafka and then using Kafka like it is. Because, well, the problem is not the protocol. The problem is basically that also the way you use Kafka, for example, consuming Kafka topic, doesn't fit that naturally to the way we typically build services having a RESTful API. And, well, things become much easier, not just by putting this part out of the services, but also taking the whole complexity out of the different services. So I hope this answered your second question.
The question was, should we use a service and deal with this problem, or use a communication protocol and kind of build our own service on top of it?
Yeah, I would. Well, I don't have I don't have an answer to it in the way that I would say it depends. It might make sense if you have enough reasons to put a service in front of it. And yeah, you're right, you have additional problems to the service. So no clear recommendation. Depends a little bit on the situation. We are even not, we even don't have a decision on whether we should go with a service in front of Kafka or not. It's something we're currently discussing ourselves. So maybe we will do an eBay Tech Talk in a couple of months again about Kafka and give you an answer about that. But we will see. So the first question I don't remember. Can you just...
Yeah, it was about, I mean, now there's a question going on about like monorepo, the distributed repos, and the question is, like, the problem with them is having the versioning and stuff, or like different problems come up with that. And there are arguments about monorepos, and we're also thinking about it, although our stack is just Java and JavaScript, which is simple, but you're using different languages as well. So what's your personal view about monorepos? Do you think it will be useful? Or, I don't know what you do with the mobile API, the repos.
So the idea is basically to put everything in a single repository, or? Yeah, I'm absolutely against that. The reason is basically having everything in a single repository is exactly the root of all the problems. So I'm absolutely against putting everything in a single repository. Every service should have its own repository. That's it. Other questions? Yeah, here's a, oh. Yeah.
Hi. You mentioned somewhere, like in the middle of the presentation, then, for example, team A creates a microservice, and then team B wants to modify it, and instead of really creating the pull request, they create the new service that is actually the copy of the first one plus adding this feature.
No. Well, yeah, you could also copy the other service if you want, but, well, this is not what I was talking about. You should just create a service that is adding the feature.
So at the end it will be like one service per feature, and...
Well, yeah, might be. Well, I would say If you distribute your features randomly across your teams, then you will have a service per feature. If you create business ownership, you get some kind of, well, you get at least the opportunity to consolidate the whole thing. So I don't say always create a new service for a new feature. I just say focus on keeping teams working independently. So if this means creating a new service because it's a different team working on the same stuff that another team was working on before, well, that's the reason why you should create a service. Well, while if you have a team that has a business ownership on, for example, customer data, well, then it's fine if the whole thing goes into a single service and every single feature is added to this service. That's also fine.
Okay, thank you.
So, other questions?
Okay. Interesting one, yes. So you have independent teams, right?
Yeah.
Standalone. Probably full stack. What about the front end? People, do you have specialized front end people, especially for mobile development, or you guys full stack unicorns who can do both the microservices and front end, and DevOps on top? So, like, if you have no dependencies at all, it means the team can handle everything end to end. So either you have full stack, either you have specialized people, but then what happens when they run out of tasks? Because it happens, right? The feature is ready visually, you still don't have microservice for it, what this guy do? Or go?
Yeah. So we have specialized people. We have, well, it depends. We have, for example, a mobile team, so all the mobile developers are working in the same team and separated from the other teams. In the case of mobile development, this makes a lot of sense. The other teams are full stack, but not, well, they have front-end developers and they have back-end developers in the same team at the same time. And yeah, you're right. It could happen that, for example, the front-end developers in one team run out of tasks. Well, the way we are dealing with that is, for example, giving them other tasks. And well, this is also one of the reasons why services are popping up in our system very frequently, because, well, tasks from the same domain will pop up in either this team or that team, depending on what is to do at the moment. In the future, we hopefully will get to a better solution for that. But in many places we have already, for example, the mobile stuff is already one team. And there's always something to clean up. And yeah, I don't see that that we really have a problem with running out of tasks in general.
Okay, my second question. Do you have any common storage and dependencies between microservices, between teams? Like people who talk to the same source of truth, not reading from it, but writing it, and then how you deal with that. Like this company, this team X has a task which involves updating cars, right?
Yeah, we don't have common storage. Each service has its own storage. So if you, well, what can happen is that one service depends on the data from another service, but then it's not accessing its database. Well, then it is consuming the Kafka log. And storing the data in its own database. So basically this is like replicating the data from one service to the other service, but including some business logic instead of replicating tables. That's the main difference. So we reuse a well-known concept that is known from database replication, but we reuse it in a way that it is used more on the business level.
Hi. You have addressed the thema of cross-dependencies between the services, and sometimes when Team A changes the data structure, it can break the backwards compatibility. As a solution, you have suggested to change the technology stack. But I don't know if, for example, they are not adding something to the data structure, but modifying or removing. That I think it doesn't matter what technology stack you're using.
Yeah, you're right. If you're breaking the format that you're emitting, then you're breaking your clients. That's simply the rule, so avoid this always. Or, well, the solution for this Kafka-based thing, for example, is simply put the new form to another topic, if it's a breaking change. It's like versioning on the API level.
And you also said it's possible somehow to automate this cross dependencies to somehow make one service know that another service.
Yeah, but you can't automate everything there. That's the problem. For example, if you have a data structure that is very simple and you can just add another property and another property and another property over time, well, that's a thing that is pretty easy to handle. And it's one kind of extension to data that's easy to manage. If it becomes more complex, like you want to restructure it completely, well, this is not easy to handle. And this is definitely, well, I would even say it's a reason to write a new service in general, instead of just creating a new topic for that. But at least, well, this is something you should handle in a different way. This is nothing you will easily automate. So this is also a reason to avoid this, of course. Whenever you can avoid this, try to avoid this. So think well about how to make your data structure reusable. One thing, for example, just to give you a simple example of what we are doing is, to not breaking clients, is don't have properties that are just true or false in JSON. Instead, we put, in many cases, we put just an empty object there, if it's empty, or we put something, or we leave it completely away, if it's false, if you want. So the advantage of this is the client really knows what happens. If it's not there, well, it's not there. If it is there, and at least an empty object, that's fine. And if you add later something to the object because you want to add some metadata, well, that's also fine. The client still knows, well, there is an object, doesn't matter if there is something in or not. Well, there's an object, I'm fine with that. So this is one kind of being very open to extension of the data.
Thank you.
Other questions? Or is everyone looking on the watch to go to the soccer match?